Okay. Uh, Here in this chapter, you should know the various definitions, notations, organize the given data in a matrix form, various theorems, properties, and operations. Okay. So now this given data, you can organize this with notebooks and pens on the column and these names on the row. The other way you can also organize the names in the column and the notebooks and pens on the row. Okay, these are the different way you can organize data. Based on you how you organize data, you should read the data. Okay, so the given data can be organized in these two ways. Yeah, matrix is an ordered rectangular array of the numbers or functions. Okay, these numbers or functions is called the elements. Okay, matrix, you write the matrix in the capital form like here A, and these elements can be numbers or the functions like this. Order of a matrix M cross N is M cross N. Okay, order of the matrix with M rows and N columns is M cross N. This is the order of the matrix. This is how you write a matrix with M rows and N columns. Okay, here important M rows and N columns. This N is a natural number. Natural number, it does not include 0. Okay, see, if you represent an element with Aij, I is representing the row, ith row and jth column. Okay, Aij, if you represent the element, let us say A12 means first row, second column. Okay. A is a matrix, this order, how you represent. Okay, real numbers, elements. This is how you represent the matrix form. So now the given data is organized men workers, women workers in the various factories 1, 2, and 3. What does the entry of the third row and the second column? This is the third row and the second column 26. Number of women workers and the third factory. Okay, this is the number of women workers in the factory 3. Okay, third row, second column. This is the mn elements in the matrix of order m cross n. If the matrix of order m cross n has mn elements, so the matrix of order, the number of elements in a matrix 8 means these are the possible orders. 1 row, 8 columns, 8 rows, 1 column. Okay, 4 into 2, 8, 2 into 4, 8, 1 into, okay. These are the possible order of the matrix, arrangement of the matrix. For the number of elements is 8. You can try for the possible order for the 24 elements matrix. Okay. So now you have to construct a 3 cross 2 matrix using this formula. Substitute for the I and j. The important thing is the I and j value starts with 1. Row and column starts with 1, not 0. Okay. In some of your other subjects, this may start with 0 index, but here in matrix starts with 1. Row starts with 1, column starts with 1. So here we are not using any sign because this is the modulus operator. Here see the modulus operator. So no sign. Why no sign? Column matrix, only one column. Row matrix, only one row. square matrix, number of columns equal to number of rows. See here, very important thing is this order of the square matrix is n, not m cross n. Normally m rows n columns means m cross n is the order, but he sees square matrix of order n, that is important. Okay, this is different from the normal order. Okay, see these are the diagonal elements 1 4 6. So they are mentioning what are the diagonal elements. Diagonal matrix. Okay, what is the diagonal matrix? See, the important thing, if the definition is given like this, Bij m cross n is said to be diagonal, so they have mentioned diagonal, but if they given this matrix with this condition Bij equal to 0, when I is not equal to j, okay, row is number is not equal to column number, those elements are 0 1, but I equal to j, there will be number like this. So from the given definition you should be able to tell what matrix is a diagonal matrix. So if they give definition like this, then you should be able to tell then it is a diagonal matrix, because Bij equal to 0 when I is not equal to j. See this 0 here, I is not equal to j. When I equal to j, there is a number here. Okay, so this is a diagonal. So here also you see order, this is one, not m cross n, this is like a square matrix order. How scalar matrix is different from a diagonal matrix. Okay, here diagonal elements are same. Okay, so again from this definition, if they give definition like this, Bij equal to 0 where I not equal to j, Bij get a constant value and I equal to j, from this definition you should be able to tell this is a scalar matrix. Identity matrix, this is all 1 when I equal to j is from the definition. Okay, see here identity matrix. Here a scalar matrix is an identity matrix when k equal to 1, but every identity matrix is clearly a scalar matrix. Okay, every identity matrix is a scalar matrix, but not the other way. Every scalar matrix is not a identity matrix, but every identity matrix is a scalar matrix. Zero matrix is represented by this. Equality of the matrices. Okay, when you say A equal to B, they should be of the same order, and each element of A is equal to the corresponding element of B. Okay, these two matrices are equal, 2 2 3 3 0 1, but these are all not equal. Why? Because here 3 is there, here 2 is there. Okay, so here 2 is there, here 3, so they are not equal. Okay, you have to try all the exercise. Ideally you should try all the exercise, but at least this is important. You see, I put try in a matrix. If a matrix has 24 elements, what are the possible order? Okay, you can try. These are some important thing I mentioned, but you should try to do all the exercises. Here you try this. So this you try, and this also. Operation of the matrix, addition of the matrix. Okay, so what are the conditions to add two matrix? The two matrix should have to be of the same order. You cannot add two matrices with a different order. Okay, this is the condition for the addition. Should be have the same order. This is the resultant matrix element A, B, A. Suppose A and B is not a same order, then A plus B is not defined. Okay, not defined. These two you cannot add. This is not defined. Negative of the matrix, negative of the minus A, we define minus 1 into A. Okay, minus A can be written as minus 1 into A. Okay, negative of this matrix minus A is given by minus 1 into A. Again, it should be of the same order when you subtract two matrices. Okay. See, this 2a minus b can be written 2a plus minus b. Okay. See here, 2a minus b, here plus sign is there. So this will become minus b. 2a plus minus b this. Computative law, a plus b equal to b plus a. You can take two matrices and try to prove this. This is correct. Associative law. Additive identity, that is a zero matrix. Zero is the additive identity. If you add, nothing is going to happen. Matrix is not going to change. That is additive identity. Additive inverse is minus a. Minus a for a matrix A, negative a is the additive inverse. Property is scalar multiplication of the matrix. Okay. You multiply a plus b with the k, that is equal to ka plus kb. Okay. These properties you can prove with the examples. They may give some matrices and they try to ask you to prove it. So using this you can how to find x. Okay, from this 3x equal to 5b minus 2a, using different this commutative law, additive inverse and additive identity. See, this is the real world problems. Two farmers, Ramakrishna and Kurucharan Singh, cultivates only three. See how you are going to organize this data. So mostly these are the practical examples. So you should read how they organized the data like this for these farmers. Farmers and for this rice variety. So how the given data is organized in a matrix form, you should go through it. Multiplication of the matrix. So again there should be some conditions to multiply two matrices, let us say A and B. The product of two matrices A and B is defined if the number of columns of A is equal to the number of rows of B. Then only you can multiply two matrices. Okay, what will be the resultant order of the matrix? Let us say C is the resultant matrix. So that resultant order is M cross P. Okay, A order of the matrix A is M cross N, B is N cross B. Then resultant matrix is M cross P. Okay, that is the resultant order of the matrix. This is how you multiply matrix. I highlighted how they are multiplying the matrix. See, AB is defined by DA need not be defined. In the above example, AB is defined, BA is not defined because they are B has 3 columns and A has only 2 rows. Okay, so that is why BA is not defined. Okay, the condition bar why BA is not defined. AB is not equal to BA. Okay. See, this is important. See, you read in the above example, both AB and BA are of different order, and so AB is not equal to BA. But one may think that perhaps if AB and BA could be the same if they were of the same order, but that is not so. Here we give an example of how to show that even if AB and BA are the same order, they are not the same. Okay, here you see A and B of the same order, but the AB is not equal to BA. AB is not, so even if they are in the same order, this is not true. Okay, AB is not equal to BA. That is, a multiplication is not commutative. Okay, addition is commutative, multiplication is not commutative. See, AB is not equal to BA. It does not mean for every pair of matrix. Okay, AB is BA. So for this matrix, AB equal to BA. Okay, for this matrix. Okay, observe that multiplication of the diagonal matrix of the same order will be commutative. Okay, AB is not equal to BA, not for every pair of matrix. Okay, this is not for the every pair of matrix. For this pair of matrix, this is commutative, that is diagonal matrix. See, two non-zero matrices can be a zero matrix. This is the resultant matrix. Okay, if the product of two matrices is a zero matrix, it is not necessary that one of the matrix is a zero matrix. Okay, here both are not zero matrix, but resultant is zero. Properties. Okay, this is associative law, distributive law, multiplicative identity. Okay, so this is the identity matrix. Okay, diagonal elements are 1. Okay, here again how they organize the data you should try. Okay, exercise, again you should try all the exercises, but at least these important things here you should try. This one try. This one. See here f of y, I don't know what is this. Okay, f of x and f of y. Transpose of a matrix. What is transpose? The matrix obtained by interchanging rows and columns of A. Okay, this is how you represent a transpose of a matrix A dash or AT. Properties of the transpose of a matrix. These are the properties. Okay, you can prove those properties with this example. Let us say like two matrices, verify that. Okay, these properties. What is symmetric and skew symmetric? A matrix A is said to be symmetric if A transpose equal to A. Okay, for all possible values of I and J, that is symmetric. Skew symmetric. Skew symmetric means if A transpose equal to negative A and for all possible values of A. Okay, this means that all diagonal elements of this skew matrix must be matrix or 0. So these are the theorems. Okay, you can go through the theorem and these are the proofs. Theorem to any square matrix can be expressed sum of the symmetric and skew symmetric matrix. Okay, this is again proof. So you can prove, you can use the theorem with this matrix and prove that theorem. Okay, using that matrix. Sum of symmetric and skew symmetric matrix. Again you try out these important things. If you have time, you can try everything. Elementary operations of the transformation of a matrix. Okay, this is how you represent interchanging row. This is interchanging column. Here we are interchanging row 2 with row 1 with row 2. This is row 1, row 2. These two are interchanged here. This is how you replace ri, row I with the multiplication. Okay, here you say column 3, we are multiplying 1 by 7 of the column 3. This is the column 3. 1 by 7 you multiply, you will get this. So this is the equation for this row. So for this second row, this is the formula. Second row minus 2 or 1. Okay, These are the definition of the inverse metric and invertible. If A is a square matrix of order n, if there exists another square metric B of the same order such that AB equal to BA equal to 1, then B is called the inverse matrix of A. In this case, A is said to be invertible. These are the conditions, okay? These are the theorems. Or the elementary operations. You have to use these are the elementary operations. Okay, again the exercises, you should try to do everything, but at least these important things you should try. Miscellaneous examples. See, the summary is very important, okay? So here again, from this definition, you should be able to tell this is a column matrix and this is row matrix. From this definition, A equal to A by M cross N is a diagonal matrix. If these conditions are given, then you should be able to tell this is a diagonal matrix. A scalar matrix, identity matrix, and these are the operations theorems, okay?